Hello everyone, welcome to the video. Today we are going to discuss the problem print all subsequences of a string. In this problem, we are given an input which is a string and we have to find or print all the subsequences possible for that string. In the past video, we have used backtracking to solve this problem. In this video, we will be using recursion to solve this problem. This will also serve as a basic introduction to the concept of recursion. We are going to solve this problem today. We won't directly jump to the solution, but go through the thinking process and gradually build the solution. We discuss the questions of data structures and algorithms on this channel in simplest words with fundamental approach. If you are new to this channel, please subscribe. Let's start. To begin with, let us first note the key things given in the question. We are given a string and we have to find all the subsequences of that string. So if we consider our example as ABC, these will be the subsequences of this string. If the example was AAA, that means duplicate characters were there, then all subsequences of this string will be these. We can note two things here. One is that we cannot include duplicates in our answer. And second is that the empty substring is not a valid subsequence. So if we consider our solution as a black box, we are getting a string S as an input and we will return a set of string as output. Set because we don't want any duplicates. So what will our function signature look like? Our function signature will look something like this. Before even attempting the problem, let us first try to understand what is a subsequence. From the example given here, what can we infer? The first thing that we can infer is that subsequence is basically some sequence of characters from the given string. What else can we infer? We can see that the characters in the subsequence are in the order in which they are present in the same string. Example, AB is a subsequence, but BA is not. The third thing that we can infer is that these characters that we pick, they may not necessarily be contiguous. For example, AC is also a valid subsequence. These three conditions together applied on a string will give us the definition of a subsequence. Let's come back to our problem. Our aim is to print all possible subsequences of a string like this. Let us say we are given any general string as an input to solve. Now somebody comes and tells us the answer to this part of the string. What do I mean by this part? Meaning the whole string except the first character. So if somebody comes and gives us the answer to this part of the string, can we use this answer to construct the answer for the whole string? Let's see. So what will be the answer to this substring look like? It will also be a set of string because it is nothing but the subsequences of this substring. Let us call the answer to this as partial result set, which is set of string. And let us call the final answer that we have to derive for the whole string as final result set. Now let's see how can we use partial result set to arrive at final result set. First thing is that we can add all elements of partial result set into our final result set. Why? Because all subsequences of this string are by definition subsequences of the whole string. So we have added some elements to our final result set. But what is it missing? It still does not have all the subsequences that start with the first character, right? And how can we derive that? We can derive that by appending our first character to all the subsequences that are part of partial result set. So we take every element of partial result set and we append the first character to that element. And then we add all those results to our final result set. So by now we have in final result set all subsequences that start with the first character and all subsequences that do not start with the first character. So we have all what we need, right? Are we done here? No, there is still one small edge case that is missing. We can see from the example that even a single character is a valid subsequence. So here also x, that is our first character, should be a valid subsequence. But will we get x in these two steps? No, 1 does not have x anyway because 1 contains only those subsequences that do not start with x. And 2 contains all subsequences that start with x, but it will not have that subsequence which only has x. Why? Because partial result set, every element of partial result set will have at least one character. And when we will append x to that element, it will at least have two characters. So it would have been great if partial result set also contained some empty string. If there was this empty string as a subsequence, then we could just add x to the empty string and we would have x also in our final result. So we note down here that the partial result set must also have the empty string as one of its elements. Now with these three things, we have successfully used the partial result set to construct our final result set. We can actually return the final result set. This final result set will contain all valid subsequences of our string. This is a very common approach of solving problem. This is the way we use recursion. So what we basically do is we are given some problem, we break it down into just next smaller problem. Now if somebody gives us the answer to that next smaller problem, we can try to use that answer to figure out our answer to the original problem. Here our next smaller problem answer was partial result set, and we used this answer to get the answer to our original problem, that is final result set. Now with these insights in mind, let us try to write the algorithm for this. So this is our original method that we were given in the question. We are given a string s and we will have to return a set of string. So we create a new method, find subsequence recursive. This is a utility method. This will be the method that will be called in each call of recursion. It is a very common practice and useful to create a new method, a separate method that will be called recursively than using the same method that we were given in the question. As always, for any recursion problem, we'll follow these 5 steps. First is identifying the recursive relation. Recursive relation basically means how will we use the answer to smaller problem to calculate the answer to the larger problem. We have already established that here, that how we are using partial result set to calculate final result set. Second step is identifying inputs. Which inputs? Inputs to the recursive call that we will be making again and again. We can identify that from the recursive relation. Based on the recursive relation, we can see that only string as an input to this call will suffice. Now let's try to write the core of our algorithm based on the recursive relation. So first our aim is to get this partial result set. Now where will partial result set come from? It will also come from the same method call, just that the input will be a smaller string, the substring except the first character. So we got the substring here, that is the substring except the first character, and we called the same recursive call on this substring to get the partial result set. Next, our aim is to put this partial result set into our final result set. So we will definitely have to declare final result set somewhere here, and we'll add all elements of partial result set into final result set. So we added our partial result set to the final result set. Next, our aim is to go through all elements of partial result set and append first character to each of these elements. Then we add those to our final result set. So we iterate over the partial result set. In every iteration, we get a string. We append our first character to that string, and we put this new string into our final result set. And finally, after all the iterations are done, we also add an empty string to the final result set. Why are we adding empty string to the final result set? Because this will serve as a partial result set for some other string. For example, if we had called this method initially with a string for a string of length 10, then here we would have called this method for a string of length 9, and when it came for 9 here, it would have been called here for 8, and so on it will go on. So final result set of some string of length 7 here will be nothing but partial result set for the string of length 8. When our final recursive call will be returned here we will just eliminate the empty string and return the remaining subsequences. Now, are we done here in this algorithm? No. Why? Because this recursion can go in infinite loop, because every time we are calling this method, we are calling the same method again. Therefore, we need to cover the third step, that is, we need to add a base or terminating condition. And when will we arrive at the base condition or terminating condition? When our input is smallest. And when will our input will be smallest? When our string is of length 1. So if our string is of length 1, what are the subsequences? That string itself and the empty string that we'll have to add and return. So now we have added our base condition here, and now our algorithm is complete. This is definitely not a very efficient algorithm. It will take time complexity of the order of n into 2 to the power n. Why? Because in every recursive call, we'll approximately have order of 2 to the power n subsequences, and we have to iterate over each of them to append our first character. The space complexity will also be around order of 2 to the power n, since we store these results in our sets. Let us now go through the code for the same algorithm that we just discussed. You can also find the link to this code in the description. So this is our original method that takes string as input and returns set of string as output. So here we call our recursive method. We have defined a new recursive method called find subsequence utility, and we pass our original string to it. From this we get the final result set. We remove the empty string and then we return it. Now how does this recursive method function? Let's see. Here is the recursive method. Here first of all we declare a final result set. We add our base condition in which we add empty string and string itself if the length of the string is 1, and we return it. Now let us come to the core of the recursion logic. So we first get the partial result set using calling the same recursive method for the substring. Then we use this partial result set in this method and we construct our final result set and return it. So how do we do that in this method? Let's see. In this method we do 3 things. First of all, let's look at the input to this method. The input is first character and the partial result set. So the 3 things that we do here is, first of all, we iterate over the partial result set. We get the string in every iteration. We append the first character to that string and we add that to our new result set. This is the first thing that we do. Second thing, we add the whole partial result set into new result set. And the third thing, we add the empty string and return it. So this way, we finally return the result set here. We remove the empty string from it and then we return it. Let us now summarize what all we did. First of all, we understood the problem with the help of an example. Then we tried breaking down the problem. We could see that if somebody gives us the results of smaller problem, we can combine those results and use them to get the results to our original problem. That means we were using recursion here. Using that, we wrote our algorithm. We also included base condition to terminate our recursion. Then we went through the code walkthrough for the same algorithm. This is it for this video. We'll meet again in the next video with some other problem. Thanks for watching.